Hey guys, here in this video we want to talk about Poisson distribution. So before we move into Poisson distribution, we are going to talk about a question on binomial distribution, which is what we discussed in our last video on probability distribution. So you can check the description for the link of the previous video. The question goes thus: in every 5 men in a village, 3 smokes. 3, which means picking 5 men in a village, 3 smokes. 3 always smokes out of every 5 men. So find the probability that out of 8 men, 4 of the 8 men smokes. So this is a typical question. It's a good question that go in line with binomial distribution. In this case, we're told that in every 5 men in the village, 3 smokes. Now we have a trial of 8 men, and we want to see the probability of 4 being a smoker and how it's going to be distributed across the 8 trial men. So it is just very simple that here we have the probability of success to be 3/5. This is because we have a statement that let us understand that out of every 5 men, 3 used to smoke. Now the probability of failure Q, or let us just call this P. So we say probability of success is 3/5. So that probability of failure would be 2/5, which is just 1 minus P. Okay, and we have a number of trial n to be 8. So we want to check if R equals 4, like 4 out of the 8 would smoke, and we want to check the probability distribution of 4 people smoking out of the 8 trial. So then don't forget the probability of x equals to R would be n combination R. That will be multiplied by the probability of success. This is n combination R. Okay, now I have to write the system. So this is n combination R. Then you now have the probability of success raised to power R. That's raised to power R. Then you have the probability of failure raised to power n minus R. So this is just the formula we talk about in the binomial distribution. So then all we need to do is 8 combination 4. Then we have a 3/5 raised to power 4. And then we have 2/5 raised to power 4. Because R is 4 and n equals 8. So if you have 8 minus 4, it should give you 4. So when you compute this, you would get a result. So, and actually we have to write this as P into X equals P into X equals to 4. So this is just the probability we're looking for. So we can just get that and find our answers to it. 8 combination 4 is gonna give us 70. So then you can write your 3 raised to power 4 as 81 over 5 raised to power 4 as 625. Then you have to multiply this by 2 raised to power 4, which is 16. That's 16 all over 5 raised to power 4. That still remains 625. So when you calculate all these together, in order not to waste our time, so you have a 81 divided by 625 times 70 times 16, also divided by 625. You would be having the probability distribution P of X equals R to be 0.232. So this is the probability distribution as far as that question is concerned. So good. You can also have deviation. You can have deviation and standard and variance. So when we say deviation, we talk about the standard deviation of this probability. So when we say deviation, in case there will be a little deviation away from the probability calculated, so should in case you are told to calculate the standard deviation of the probability distribution, it is just standard deviation SD is equals to square root of number of trials times probability of success times probability of failure. Just so you know, probability of failure is Q. So this is the standard deviation in case there is deviation. So then the variance is the square of standard deviation. So variance is gonna be equals to the number of trial multiplied by the probability of success, then the probability of failure. So that is that in such case. So then let's now move straight to Poisson distribution. Now, binomial and Bernoulli's distribution are used when the number of trials are very small. So in this case of Poisson distribution, in the case of Poisson distribution, in the case of Poisson distribution, we are talking about when you have a large number of trials and then the probability of success is very, very low. So then you can apply the Poisson distribution. So the Poisson distribution in that case would be this probability of X equals to this raised to power X itself multiplied by E raised to power minus this all over X factorial. Okay, this is a factorial notation. So this is formula for Poisson distribution, and then this is called the number of trial times probability of success. So this is the Poisson distribution. Now This is applicable when the number of trials is very large, and then the probability of success is low. For instance, in a farm, an industrial farm where 2 bars of yam are produced, I'm going to cite an example with that. So if you have a lot of yam produced in that case, and by uh, by experience or by physical count, you could see that about 10% of the a given sample of yam are always defective. So 10% are defective. So we are actually looking for those that are defective. So the probability of getting the defective ones is P of success, that in that case. So we say that P success is going to be 8 over 100. Okay, sorry, 10. Since we're talking about 10%. So since the question says that out of a given sample of 2 bars of yam, the population of samples, 10% are always defective. So it means that you have 10 over 100 as probability of getting defective 2 bars of yam. So now the probability of success is 10 over 100. So you do not need probability of failure in this case, because if you go through the formula, okay, something has been omitted here, and that is probability of success. So if you go through the formula very well, you would see that you do not need the probability of failure in order to use the Poisson distribution. So all you need to do is, since you have a probability of success now, which is equivalent to 1 over 10. So all you need to do is just substitute what you have into the formula. Now, suppose, okay, the question is not yet complete in construction. So let's say the probability of success is always 10%. Now, out of about 1,000 samples, now this is the number of trials. So in a farmland, we believe that the harvested 2 bars, 10% of it are always defective. Now we're talking about a sample space now, a number of trials, that 1,000 yams out of the 2 bars. What is the probability that out of the 2 bars, 1,000 yams, then you have about 4, okay, let's say fewer than 4, because there are ways you should go through Poisson distribution question. Take for instance, the question says that the probability of, let's put it this way, 8%, 10% of yam 2-bar produce on a farmland are always defective. Now, we are trying to look for the probability that out of 1,000 2-bars, we are going to have fewer than 4. Fewer than 4 means it could be 0, it could be 1, it could be 2 or 3. When we say fewer than 4, it cannot be 4. So which means we have 0, 1, 2, 3. Those are the numbers fewer than 4. That would be defective out of 1,000. So how do we approach such question? So we approach the question in this way. Now, we already know the probability of success from the first statement, that this is it. So now the next part of it is to talk about how to calculate the probability of having fewer than 4 out of 1,000 samples that is given in that case. So now, when we say fewer than 4, we are going to take the probability of x to be 0 first. Since it is fewer than 4, we're going to find that plus the probability of, if it is 1, plus the probability if it is 2 plus the probability if it is 3. So these are the numbers fewer than 4. So if we are just talking about just 4, we are not going to do it this way because we talk about fewer than 4. Since it is fewer than 4, it could be 0, it could be 1, it could be 2 or 3. So we have to add the probability of all the numbers fewer than 4 in order to get the right answer. Now don't forget the formula to find the probability, which is this. So in that case, the number of trial n is 1000. Now since the number of trial is 1000, the probability of success is 1 over 10. So we are trying to find this, which is NP. So all we'll be having is 1000 times 1 over 10, which is 100. So this actually gives 100. So we just have to go through and substitute what we have into the formula. So to find the probability that it is 0, probability of having 0, probability of 0, which means x is 0 in that case, would be this with raised to power 0, then e raised to power minus 0, oh sorry, e raised to power minus 100, because if you follow the formula well, you're gonna have minus lambda. So you have e raised to power minus 100, since we've calculated that to be 100, all over 0 factorial. So having this, we should be having 1 times e raised to power minus 100 all over 1. Yeah, because 0 factorial is 1. So what we left is to evaluate the e raised to power minus 100. So and that gives us 3.72 times 10 raised to power minus 44. So probability that is going to be 0 is 3.72 times 10 raised to power minus 44. So then we need to get a probability that it is 1. So probability that it is 1 is gonna be 100 raised to power 1 e raised to power minus 100 all over 1 factorial. So that is it. So going through what we have there, we are just going to have 100 times e raised to power minus 100. So 3.72 times 10 raised to power minus 42, as 1 factorial is also going to give you 1. 1 factorial is also 1. So we have 3.72 times 10 raised to power minus 42. So probability that it is 1 is 3.72 times 10 raised to power minus 42. So we also need to get a probability that it is 2, and that will be 100 raised to power 2 times e raised to power minus 100 all over 2 factorial. So having this, we should understand 100 squared is going to be 10,000. So that will be multiplied by e raised to power minus 100 which is 3.72 times 10 raised to power minus 40 divided by 2, which is 1.86 times 10 raised to power minus 41. So this gives 1.86 times 10 raised to power minus 41. Then we get a probability that it is 3. Since we're talking about fewer than 4, so the probability that it is 3 is gonna be 100 raised to power 3 times e raised to power minus 100 over 3 factorial. So 100 raised to power 3 is 1 million. This multiplied by e raised to power minus 100. So that's 3.72 times 10 raised to power minus 44 divided by 6, which is 3 factorial. Okay, let's take it again. 100 raised to power 3. Then you multiply this by e raised to power minus 100. Then you have to divide. Okay, that is 3.72 times 10 raised to power minus 38 divided by 6. So that gives 6.2 times 10 raised to power minus 39. So probability that it is 3 is going to be 6.2 times 10 raised to power minus 39. So the sum of these probabilities gives you the probability that it is fewer than 4. So if you have to continue with that, you just have to add the probabilities in standard form and you get your result. So this is a typical question application of Poisson distribution. That's the typical example on Poisson distribution. And Poisson distribution could also have deviation. So the deviation for Poisson distribution could be square root of lambda. So let's say the standard deviation for Poisson distribution is square root of this. And don't forget that is square root of NP. So the variance would just be NP. If you like what you see, endeavor to click on the subscribe button and also turn on the notification bell and try to share our video and give a good comment. Thank you.